Um, Welcome back to another lesson on Kirchhoff's law. Students, today we will be focusing on Kirchhoff's law. Kirchhoff's double H. Kirchhoff's Kirchhoff's law. And so we'll be looking at the problem that someone asked us, which was problem number 1. And very basic circuit. So what I would do is, first of all, to solve this question, I would redraw the circuit. So let's redraw the circuit together. So we have the circuit redrawn. So we have a internal resistance 0.2 and 110 volts. Okay, and let's draw it this. And on this side we have a 0.25 and we have 100 volts altogether connected to another circuit over here with a 200 and 20 volts, and an internal resistance of 5 ohms. So I think this is basically straightforward. um, After this we are going to apply Kirchhoff's law. So basically, to solve Kirchhoff's law, you have to the first step to solving Kirchhoff's law is you have to simplify the circuit, and then the second step is to simultaneous equations, right? So simultaneous equations. So we'll have simultaneous equations. Basically, we require 1, 2, or 3 equations, which will which will which will sorry which we need to solve for. So when you have one unknown, it's very easy to solve. Two unknowns, very easy to solve. Three unknowns, it's possible, but I prefer using the calculator. For unknowns, definitely using a calculator for four unknowns. But for the syllabus, I think mostly we will be focusing on two unknowns, or sometimes the third unknown. So to solve this problem, we have to create our simplified circuit and then follow up with equation 1 and equation 2. Not that difficult, so let's simplify the circuit. So we're going to take internal and external, right? Let's copy this, copy it, copy. Let's simplify our circuit, paste it over here, paste it, move it up. So if you guys, one note is that you guys have to look at you guys have to look for Kirchhoff's law. You guys have to look at the bigger circuit. Remember, like in electric circuit as well as in real life, the bigger person is always going to overpower the smaller person because of their size and their strength. So we are going to choose the 220 and the 110 as our power sources, and then this 100 volts will become the resistance. Okay, basically what that means is like okay, so remember, in a battery you have a positive and a negative terminal, right? And if two batteries are connected in this sequence, we are going to add them. But if they are connected in the opposite sequence, like such, we're going to have to subtract them. Very simple, right? So let's break the circuit up. So let's paste it out. Let's paste it again. Paste it as well. What we're going to do now is we are going to create equation number 1. So let's remove this, right? And let's focus on the circuit. So what you need to remember is electrons move from negative to positive, and then the current moves from positive to negative, right? So we are going to focus on this circuit, right? So basically to solve Kirchhoff's law, we are going to, okay, um, most people don't do this, but I do this, and basically it's Newton's law of conservation, but I like to apply it here as well. So you know that energy in the system is equal to the energy out of the system, right? So the voltage, the sum of the voltage in must equal to the sum of the voltage out, right? So we are going to have our internal voltage, voltage inside plus voltage inside equals to voltage out plus voltage out. So if we go over here to our circuit, we are going to look at the diagram, and we notice that we have a positive line and a negative and a positive and a negative. So we're going to follow the current, right? So over here our voltage is positive. This resistor is going to create a resistance, so it's going to be negative. It's going to travel, it's going to go this distance, and it's going to come down, and this resistance negative. Okay, and this battery, because it's in the opposite direction, you see, if it's the same direction, so if you had 12 volts, you're going to get 24 volts. So it's basically maths. So over here we can see that they are in the opposite direction, so this is gonna be negative as well. Okay, so let's put that down on the diagram, on sorry, not on the diagram, let's put it on the equation, right? So what we're going to have is our voltage in, which is 110, remember, the biggest voltage, right? And then we have negative resistance of 2, resistance of 0,2, right? And then what we're going to do is multiply it by I. So we know from Ohm's law, right, that voltage is equal to I R, right? So we're just going to replace this voltage with I1 multiplied by R1, right, equals to, so it's not actually voltage in and voltage out, but it's just something I like to do to remember. But over here we'll have a voltage of 100, and then it has an internal resistance, so positive internal resistance of I2, sorry, I2 R2. So now let's simplify this equation. So we're going to have 110 minus, we're going to take the 100 over, minus 100 volts is equal to I1 multiplied by the internal resistance is 0,2, right? We take it over, sorry, equals to negative I1. 0 comma 2 plus I2 um, 0 comma 2 and I2 is 0 comma 25 0 comma 25. So what we have here is current I1 flowing in this direction, and then we have I2 in this direction, and then we have I3 in this direction, right? So we'll get back to that. I1, I2, I3. Okay, so now we're going to simplify this equation, and we're going to get 10 volts is equal to negative is equal to positive, sorry, is equal to I2 to 0 comma 25 minus 0 comma, let me write it a little bit bigger for you guys. So we're going to have mathematically 10 volts is equal to I times R, current times resistor, is equal to voltage of 0 comma 25 I2 minus 0 comma 2 I1. So this now is our equation number 1. So now let's do the circuit again. So we have our first equation, we simplified it, so we need to simplify it again. Sorry, we need to simplify the circuit again and then have a second equation. So let's do that and simplify it again. Let's copy this so it's easier. Copy, and then new page, paste. So now we are going to simplify it, and going to simplify this thing. Let's make this I3, make this I1, and let's make this I2. Okay, so now we are going to choose, okay, let's leave it as is. This is I1, this is I2. I1, I2. So now let's remove this here. Now let's solve for this equation here. So what we have here is I3, and over here we have I1. So I1, I2, I3, sorry, and I2 is here in the center. So now what we are going to do is voltage equals to I multiplied by R. So we have 220 plus I3 5 equals to, the voltage on that side is 100 plus 0 comma 2 I1, right? So now let's simplify that. 220 minus 110 is equal to 0 comma 2 I1 plus 0 comma, no, sorry, 5 multiplied by I3, right? So we're going to 0 comma 2 I1 is plus 5 I1 plus I2. 2, right? Because what we're going to have is, if we look at the question, um, if we look at the question, it says that I3 is equal to I1 plus I2. So that is why I did not want to change it. So I3 is equal to I1 plus I2 on the question paper. And now over here we have an answer of 220 minus, sorry, let's look at this again. This comes, this is taken over here and that is taken over there, right? So over here we have 220 minus 110 is equals 110, right? And then our equation is going to be 110 is equal to let me just get a calculator quick. We have negative, so we have 0.2 minus 5 equals to negative 4.8 I1, and then we have negative 5 I2. So now this is our equation 2, and we have two unknowns. We have I1 and I2 as our unknowns. So let's copy this and solve. Copy. Paste. That's our first equation, equation number 1, and this is our equation number 2. Copy, paste. Equation number 2, equation number 2. So now we are going to solve for these two equations, and we need to eliminate one of them, right? You can do it mathematically, or you can go to your calculators. What do I feel like doing, calculator or the normal method of solving this equation? Um, what? Okay, so this calculator does not have that function, so basically we are just going to have to solve it the old method, and I'm thinking everyone else does not have a scientific calculator, so let's solve this equation. What are we going to do? To solve this, pretty straightforward. We have to remove one of them. How do we remove one of them? So we take equation 1, so let's remove I1, right? Let's remove I1. So for equation 1, we're going to equation 1, we are going to multiply it by negative 5, and equation 2, we're going to multiply it by negative 0 comma 2, and then we have an answer here of, let's do that, equation 1 multiply, so we have 10 10 multiplied by negative 5. So we have negative 50, 0.25 multiplied by negative 5. We have equals to negative 1 comma 25 I1. 0.2 multiplied by negative 5, we have negative 1 I2. And then for equation 2, we have 110 multiplied by negative 0.2, which is negative 22, equals to negative 4.8 multiplied by 0.2 is equal to negative 0.96 I1. Then we have negative 5 multiplied by negative 0.2, which is negative, 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 positive, negative, 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 positive 1 I2. So now to solve this, what we're going to do is subtract them. So 1 minus 1 is 0. And then over here we have negative 50 minus 22 equals to negative 28. And over here we have negative 1.25 minus 0.96, and we have an answer of negative 0.29 I1. And you know, to solve this equation, pretty straightforward. I1 is equal to negative 28. So 28 divided by 0.29, and our answer is answer is our I1 is something looks wrong. Let's go on top. We have our equation 1, which is negative 10 0.25 negative 0.2. Maybe I made a mistake here by multiplying negative 5 multiplied by negative 5 multiplied by 0.25, negative 1.29, negative 0.2 multiplied by negative 4.8, 0.96. So we have negative 1.25 plus 0.96 equals to 0.29. So we got 28. Negative 50 plus 22 equals to negative 28. 28 over negative 0.29. Okay guys, I think what we done here is we made a mistake, cause like when you multiply two fractions, it actually gets smaller instead of getting bigger. I forgot about that mistake. So to make a note is that don't multiply fractions. It makes things way smaller. So what we're going to do is we just have to then negative 0.25 multiplied by 5 divided by, so negative 0.2 multiplied by, okay, so we're going to take the first equation and we're going to multiply it by 25. So let's multiply everything by 25. So we have we have 10 multiplied by 25, we have 250 equals to 0.25 multiplied by 25, we have 6.25, And then over here we have negative 0.2 multiplied by 25, we have negative 5 I1, right? At the bottom we're going to have 110 equals to negative 4 comma 8 minus 5I. We are going to then negative 5 plus 5, we're going to have 0 over here, 6.25 minus 4.8, we're going to have 11.05, and over here we're going to have 250 minus 110 equals to 140. So over here is your I1, if I'm not mistaken. I1, I1, I1. And our I1 is equal to 140 divided by 11.05. Not giving me the correct answer. Let's make sure we have the equations right. So we have 10, 0.25. Okay. So apparently I made a mistake here. This is I2 and this is I1. So let's do that again. Let's make sure, double check. Okay, so as you can see, 0.25 is actually I2, so this must be 0.0,25. This must be I2, this must be I1. Okay, and then solving this equation shouldn't be that difficult. Delete, erase, okay. So now 0.25 multiplied by 20. Okay, so now we're going to multiply by 20. So we have 200 equals to 0.2 multiplied by 20 equals to, so we have 4I1 negative 4I1 plus 0.25 multiplied by 20 equals to 5I2, and then over here we have 110 equals to negative 4.8 I1 minus 5I2, right? So now we're going to add them. So 5 plus negative 5 is 0. We have negative 4 plus negative 4.8, which is negative 8.8, and over here we have 310, and we're going to divide that to get our I1, which is 310 divided by 8, negative 8.8 equals to, we have an answer of negative 35 amps. So basically what that means is, if you have a negative, that means that your assumption is in the opposite direction. Nothing much. If you have a negative answer, that just means that the current that you assumed is actually flowing in the opposite direction. This okay guys, I think I made another mistake here. This should have been 5 comma 2 I1 I2 5. So this here must be 5 comma 2. So let's correct that. 110 0. So, oh sorry, negative 4 minus 5, negative 4 minus 5.2 equals negative 9 comma 2, and then we have I1 which is equal to 310 over negative 35 negative 9.2, and your I is negative 3 comma 3 comma 69 amps. Wait, now to solve for the next equation, basically what we're going to do is use this and substitute it in one of the equations. So let's use one of the equations. Let's use this equation. So we have 10 equals to negative 5 comma 2 I1 minus 5 I2. So now let's solve it. Let's substitute this into equation. So we have 110 minus 5.2 multiplied by negative 33, which is equal to we have negative 61.6 equals to negative 5 I2, and then our I2 is equal to divided by negative 5, negative 61.6 divided by 5 divided by 5, 12.32 amps. Thank you, and I hope you guys enjoyed that video. That would be the end of this lesson. Thank you.